Hi, this is Deshmukh-Nikam, Assistant Professor. This video is regarding the practical demonstration of practical determination of the saturation solubility of the given drug at room temperature. This practical is included in the SY-BPharm syllabus under the subject Physical Pharmaceutics 1. So the aim of today's experiment is to determine the solubility, that is, saturation solubility of given drug at room temperature. These are the references in list over here which are referred for this experiment. Requirement: first, chemical, that is benzoic acid or any drug, distilled water, ethyl alcohol, 1% normal sodium hydroxide, phenolphthalein indicator, etc. Apparatus or instrument used are pipette, conical flask, stirrer and beaker, etc. Principle involved in the saturation solubility determination. Solubility is an intrinsic and a physical property of the solute. It is the maximum amount of solute dissolved in a solvent to form a saturated solution at a certain temperature. That means at a certain temperature, the solubility will vary. Quantitatively, solubility is the concentration of solute in the saturated solution at a certain temperature, and qualitatively, solubility is a spontaneous interaction of two or more substances, that is solute and solvent, to form a homogeneous molecular dispersion. Then, under this saturation solubility, the concept of like dissolved like is there. So there is an interaction between the solute and solvent, and it's depend upon the like dissolved like concept. If the solute and a solvent intermolecular forces are similar, then the pair will be soluble, that is polar dissolve polar. Example, salt and sugar will dissolve in water, and a non-polar dissolve in a non-polar. Example, naphthalene dissolve in a benzene. So if a solvent is considered as A and solute is considered as B, and the forces of attraction are represented by AA, that is, the force of interaction between the solvent molecule is AA, the force of interaction between the solute molecule, that is BB, and the force of interaction between the solute, that is a solvent, and solute molecule will be represented as a AB. So if AB is greater than AA or BB, that means the force of interaction between the solvent and solute molecule is greater than the force of interaction between the solvent molecule or a solute molecule, or these three forces are equal, then the solute will be dispersed and form a solution. So saturation solubility is a equilibrium solubility and is the concentration of amount in a saturated solution when expressed solid is present and the solution and solid are at a equilibrium. There are two steps involved in the determination of saturation solubility. First is preparation of the saturated solution. The substance is added in a solvent at a particular temperature. It's based on the effect of temperature. Then the next part is the analysis of saturated solution. So for analysis of saturated solution, there are different methods for the analysis. Those are enlisted over here. That is the evaporation method, volumetric method, that is a titration method, gravimetric method, that is a precipitation measurement, and an instrumental method. In instrumental method, we can use UV spectroscopy and a chromatography, that is HPLC or TLC. In this experiment, we are going to use the volumetric method for analysis of the saturated solution. So as per USP, that different terms of solubility can be expressed As per USP, that is a descriptive term, and the relative amount of solvent to dissolve one part of solute. So in case of very soluble, less than 1 part of solvent to dissolve 1 part of solute. In case of really soluble, from 1 to 10 part of solvent to dissolve 1 part of solute. Soluble, that is from 10 to 13 parts of solvent to dissolve 1 part of solute. Sparingly soluble, from 30 to 100 parts of solvent to dissolve 1 part of solute. Slightly soluble, that is from 100 to 1000 part of solvent to dissolve the 1 part of solute. Then very slightly soluble, from 1000 to 10,000 part of the solvent to dissolve 1 part of solute. And insoluble or partially insoluble, that is more than 10,000 part of the solvent to dissolve 1 part of the solute. So these are the solubility expression. From that you will get the idea of the solubility. So procedure used for the determination of saturation solubility is: first, in a beaker, take 100 ml of distilled water and add drug sample, for example salicylic acid or a benzoic acid, in a small amount of drug with the stirring to prepare the saturated solution. So this method, till this we can prepare the saturated solution. Then filter the solution to remove the undissolved drug particles using wet filter paper. Then in third next step, in a conical flask, take 10 ml of filtrate and add 9 ml of water and titrate against 0.1 normal NaOH using phenolphthalein as an indicator. The end point of this titration will be colorless to pink. Next, note down the burette reading and perform the same titration in a duplicate. Then calculate the normality and solubility of salicylic acid or benzoic acid. Then identify the types of solubility as per the USP solubility expression. So in the observation, the room temperature, whatever the temperature at point of experiment, you have to write in that observation. In the observation table, first serial number, second, in this case we are using distilled water, so distilled water plus salicylic acid or benzoic acid. Then volume of NaOH, that is V2, that is a burette reading. We have to take it in a triplicate and then you have to take an average of it. Then normality of benzoic acid or salicylic acid and solubility of benzoic acid. So in the calculation part, that is salicylic acid or benzoic acid, 1 stands for salicylic acid or benzoic acid and 2 stands for NaOH. N1 is the normality of benzoic acid or salicylic acid. V1 is the volume of benzoic acid. V2 is the normality of NaOH. And V2 is the volume of NaOH. That is the burette reading. Then the formula for calculation of solubility will be the normality that we are get from the last slide calculation into gram equivalent weight of the salicylic acid or benzoic acid, which we are given, that is in case of salicylic acid is a 138.12 and in case of salicylic benzoic acid is a 122.12. Okay, so from that you will get the solubility. Okay, then result, the solubility of given drug, that is salicylic acid or benzoic acid in water at that temperature, for example 25 degrees Celsius, was found to be dash dash. So now we will see the demonstration part of it. So in the demonstration part, we will see first step, that is preparation of saturating solution of benzoic acid. So that will be the first step. For that, as we have to determine the saturation solubility of benzoic acid in water. So first we have to take the 100 ml of distilled water. So in a In a measuring cylinder, I have taken the 100 ml of distilled water, and now I'm going to transfer it into the beaker. As we have to prepare the saturation solution of benzoic acid, so now we are going to add a small quantity of benzoic acid so that it will form a saturated solution of benzoic acid. So addition is with the continuous stirring, as the stirring may also affect the solubility. So we are continuously adding the stirring that solution. So after the solution is prepared, we have to filter that solution so that we can remove the undissolved part. The next step is titration of saturated solution of benzoic acid with the 0.1 normal NaOH solution. So after the filtration, we got this filtrate. Now we have to take 1 ml of this filtrate, and that 1 ml of filtrate we have to transfer it into the another conical flask. Then we have to add the 9 ml of distilled water into it so that it will form a 10 ml of the solution. So now our solution for titration is ready. That is 1 ml of filtered and 9 ml of distilled water. Now for this titration, we are going to use phenolphthalein as an indicator. So now I'm going to add 2 drops of phenolphthalein indicator. For titration, we are going to use 0.1 normal NaOH for the titration. So this is prepared 0.1 normal NaOH that we are going to use for this titration. As we have already discussed, the end point of this titration is colorless to pink. So now I'm going to slowly adding the NaOH dropwise addition to the below solution, and this will be the end point, that is a clear pink color. That will be your end point of your titration. So now note down the burette reading. As we have already discussed, we have to perform this experiment in a triplicate. Then calculation for this solubility determination of benzoic acid in water. As you can see over here, there are 3 readings written over here of burette reading. The first one, as you can see, that is 0.2 ml first burette reading, second burette reading 0.3 ml, and third burette reading is 0.2 ml. And the 0.221 will be your average burette reading that we are going to use in the this equation, that is N1 V1 is equal to N2 V2. So N1, that is the normality of benzoic acid, will be N2 will be 0.1, that is the normality of NaOH that we have. There is one correction, there must be N2. Then V2 is the burette reading, that is 0.221, and V1 is the volume, that is 100 ml. Okay, so by using this equation, you will get the normality of benzoic acid, that is 0.00221. That is the normality of benzoic acid. So now we are going to use a simple formula for determination of solubility, that is normality into mass equivalent into volume of solution in the liter. So that is 0.0221, that is we are get from this from the above calculation. Then mass equivalent is 0.2212 and the 1 liter, so it's 1. So your final answer will be 0.269 milligram per ml. That is the saturation solubility of the your drug. So 0.269 milligram per ml is the solubility of benzoic acid in water. the questions which under this experiment is the first, give the quantitative and qualitative definition of the solubility. Second, define saturation solubility and enlist a method to analyze the saturation solubility. Then what is the solute and solvent interaction? Fourth, what is the evaporation method to determination of solubility and enlist this formula? Brief on solubility expression as per the USP and mention the application of above experiment in the pharmacy. The answer of these all questions you will get in this video. So this is the small explanation, demonstration of the experiment, determination of saturation solubility. Okay, so I hope this video will be helpful for you all, and thank you.